So now we're going to study about Kepler's laws of planetary motion. And these laws explain the motion of planets in their orbits. And the first law states that the planets move in elliptical paths. Although they look like circles, but they are not exactly circles, they are ellipses with a little bit of eccentricity sometimes, and sometimes large eccentricity. So when we are saying that planets move in ellipses, it means that the planets will move in a path something like this, like an ellipse. So it will have two focal points. So in order to draw an ellipse, before we start this, let's try to draw an ellipse. I've taken two pins and I've put a thread over these pins, and let us just try to draw an ellipse with it. So with this thread, if you traverse around in this manner, what you make is an ellipse. Okay, and these 2 points, they are actually the focal points of the ellipse, and this is the major axis and this is the minor axis, and this is half of the major axis and this is half of the minor axis. So let's try to draw it very clearly. So this is the ellipse and it has two focal points. Let us say this is F1 and this is F2. And so there are some properties of ellipse which we are going to study. So this is an axis which, because it is a smaller axis, so we call it as the minor axis of an ellipse, while this axis, which is the larger among the two, is called major axis. And the sun will be at one of the focal points. So let us say that the sun is somewhere here, and the earth, let us say, is here. Earth or any other planet. And F1 and F2, they are the two focal points of ellipse. And sun could be at F1 or at F2. If it is at F1, then F2 will have nothing, so we won't have anything here. We just have sun at F1 and that's it, and earth is moving in this path around it. And so this distance from here to here is A, and because it is a major axis, it is half of the major axis, so A is also called semi-major axis. While this distance, the half of the minor axis, it is called semi-minor axis. And the distance from one of the focal points, this distance is C. And because the minor axis is just at the center of the ellipse, so F1 and F2, they will be at equal distance and it will be also C. So from the center, F2 and F1, they are at the equal distance. And how much eccentricity an ellipse has depends upon a factor which is called E. E is called the eccentricity of ellipse, and it is given by C upon A. C is this distance upon A, and the semi-major axis and semi-minor axis are related by b squared plus c squared will be equal to a squared. So a is the largest distance of all. So b squared plus c squared will be equal to a squared. These are all the properties of elliptical motion, and we need to know all these relations so that we can use them for solving problems based on these expressions directly. So b squared plus c squared is equal to a squared, and eccentricity is equal to c upon a, and eccentricity varies from 0 to 1. Now it means that the eccentricity, when there is no eccentricity, it means that E will be equal to 0, and E will be equal to 0 when C will be equal to 0. So if C is 0, then if we use this equation, then B will be equal to A. So if both these distances, they are equal, it means it is a circle. So a circle is an ellipse with eccentricity 0. Therefore, in planetary motion, sometimes we'll use expressions that are used for circular motion, because circle is a type of ellipse in a particular situation. Like in this case, if eccentricity, circle is a type of ellipse where eccentricity is 0, then it is a circle. Okay. And when Earth is moving around the Sun, then when it is here at this point, it will be at the maximum distance from the Sun, and this will be the maximum distance. Maximum distance from the Sun, and this distance will be a plus c. So it will be a plus c. It is the maximum distance of the planet from the Sun, and we call this point as apogee point, a scientific term for this point, and it is also called aphelion. Aphelion point. While when Earth reaches somewhere here, then it is at minimum distance from the Earth. So we say that this is the minimum distance of any planet, like we're talking about Earth, minimum distance of planet from Sun, and it will be equal to a minus c, because we need this distance and total distance is a, so a minus c will give you this distance, and this point is called perigee point, or it is also called aphelion point. Just the name of this point. Okay, that's all.